One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and it's the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey guys, welcome back to the podcast. We're still talking about, I guess this is part 11 of the functional hierarchy of health. We're in the subsection of the immune system, and today we're going to be talking about the CBC and the differential. So last episode, I did a super quick and very high-level overview of inflammation. And again, as I said, we're going to shift the conversation today to infections and how they might show up on a lab test, specifically on the white blood cell portion, what we call the WBC. I'll probably use white blood cell or WBC interchangeably. And that's part of a lab test that's pretty much run on every single person on a frequent basis, and that's called the CBC, or the complete blood count. So let's talk about infections first. I'm going to start about making a distinction between acute infections and chronic infections. Now, everybody knows that there is a cold and a flu season. Like every year, millions of people get sick with common viruses, and the NIH, the National Institute of Health, tells us there's actually about 200 viruses that can cause the common cold, but about one third, about 33% or so of all of these colds are caused by a group or a family of viruses called rhinoviruses. And that's rhino as in like rhinoceros, obviously referring to your nose. So again, this is a family of viruses. There's not just one type. But the larger point to make here is that these viruses that are associated with cold and flu season, they come and go, but they do repeat season after season. And same thing with the flu, which is typically caused by influenza A or influenza B viruses, of which there are many subtypes, but they're not the only ones that can cause it. They're just the ones that are most common. And pretty much every cold and flu season, as it relates to things like flu vaccines, it's kind of a guessing game because nobody really knows whether it's influenza A or B or some other flu type or a combination that's going to hit the population next year. And so scientists kind of do their best guess. They track trends in other parts of the country that are getting their cold and flu season earlier than we are, and then they make their best guess as to what's going to hit us this year. And sometimes the flu vaccines can be quite effective. Sometimes they're not effective at all. And the effectiveness may actually vary from person to person. I'm sure you know people who religiously get the flu shot and they never get the flu, and others that decide not to get the flu shot because they just maybe for one reason or another don't believe in vaccines, or they would prefer to handle things naturally. And then there are people who, like me, I remember when my kids were young, I was a clinical director in a multidisciplinary clinic down in South Florida. And one year I decided to get the flu shot because I was just sick of getting sick myself because all of my kids were coming home from school with colds and flus, and it just got passed around. This is just what happens at a certain stage of life when you got a bunch of young kids, and we had 5 of them. And so I just decided, heck, I've never had a flu shot before. I was probably in my mid-30s at this point. So I got it, and darn it, I got the flu for 2 weeks. And I'm pretty sure it was actually from the flu shot. That's obviously a sidebar, just a kind of an interesting note. But going back to the core topic, this idea, the key concept here is seasonality. And so these viruses, they come and they go, and they swing back around next year, season after season, causing these acute episodes, these acute infections that affect us for a while. But eventually, after a short period of time, our immune systems gear up, and eventually we overcome the infection, and then it's gone, perhaps until the next year or the next season. But there are certain viruses that once we get them, we have them for life, right? There's no seasonality to this. There is what we call persistence, or what immunologists call latency. And this viral persistence or viral latency is possible because certain viruses have this amazing ability to evade detection by our immune systems, and that allows them to quite literally hide inside our own tissues, inside certain cells, whether those are T cells or B cells or macrophages, different tissues in the body. And it's a matter of which ones they have and do they have control. I'm sorry, let me back up because I think I just kind of skipped a concept here. But basically what happens with this viral latency is that the immune cells evade detection, hide inside our cells, but all the while have the potential to chronically but silently activate inflammation, right? So when I teach weekend seminars, I tell doctors that really it's never if their patients have chronic infections or chronic viruses. It's a matter of which ones do they have and do they have control of the viruses that are already inside their system? Because we tend to think, well, if someone's infected with a virus, they must have gotten it recently. And that's what I'm trying to point out here is that there are a handful of viruses and certain bacteria, but mostly viruses that display this characteristic of persistence or latency. They just live inside our body. And here's why I say that. Just let me give you a couple of examples. Most of you have probably heard of the Epstein-Barr virus. It's usually abbreviated EBV, Epstein-Barr. And this is the one that causes mononucleosis, or again, commonly called mono. And chances are that if you didn't have acute mono yourself as a kid or as a young teenager, you probably know someone who did. And maybe you or they missed a few weeks or perhaps even a few months of school. It's very contagious. It's called the kissing disease because it's usually passed among young adults and teenagers. But here's the deal. Almost every single adult in the country has the Epstein-Barr virus in their body, right? If we took 100 people off the street completely at random and tested them for Epstein-Barr, we would see about 95% of those adults would show evidence that Epstein-Barr is indeed in their system. Now, that doesn't mean they have mono. It doesn't mean that they're currently sick. It just means that somewhere along the way, they picked it up and it's in their system. And while almost all adults have Epstein-Barr in their bodies, and they almost all certainly picked it up in adolescence, only 1 in 4 of teenagers who get Epstein-Barr infections actually get the acute mononucleosis. And what that means is that 75% of young people, again, which is typically when we pick up Epstein-Barr, so about 75% of people, young people who get Epstein-Barr, which is almost all of them, 3 out of 4, they never had an acute infection. Never had it when they were young. They never had it when they picked it up. And so we almost all get infected when we're young, but most of us never have had the acute infection called mono. And what happens is that we go through life, because Epstein-Barr lives in our body once we pick it up, whether we're sick or not, doesn't matter. What happens as we go through life and we kind of add layer upon layer of stress and metabolic issues and environmental exposures. All of these things get heaped upon us year after year. And for some people, this breaks their immune tolerance and competence. And these viruses, which were previously content to simply hide quietly in their bodies, these viruses reactivate and then can create either persistent low level or sometimes acute and significant immune responses. Another virus that does this is shingles, also called herpes zoster or varicella zoster. Stats tell us that about 99.5% of people born in the States, particularly before 1980 when vaccines started to roll out, but prior to 1980, almost 100%, 99.5% of people in the States were infected with the shingles virus. And these little critters like to live in the nerve roots along your spine, which is why when you're an adult and you get a shingles outbreak, which is a very painful rash that breaks out along a very distinctive pattern that follows the course of a nerve when it's infected. And so, again, stats tell us that 1 in 4 adults will have at least one shingles outbreak in their lifetime. And some will have multiple, right? And we can tell a similar story for different viruses, things like human herpes virus 6 or HHV6. That infects more than 90% of the population before the time that they're 3 years old. So again, we pick up these viruses in abundance when we're young, and as long as our immune system is relatively robust, we're fine. We live not quite in a symbiotic relationship, but at least they don't bother us and we don't bother them until we lose control over our own immune system, and then these viruses come out to play. And then there's cytomegalovirus, which 85% of adults get cytomegalovirus by the time they're 40. So you see this picture, right? And while we pick up these viruses in our youth, as we age, and again, as our immune system becomes more and more compromised, the probability that one or more of these viruses that we already have and have had for years, if not decades, the probability that they will reactivate and perhaps mess up your immune system, that probability gets higher and higher. So let me say it again, and let me make this more personal to you. It's not a question of, do you have a viral load? You do. I can almost guarantee it. But it's whether or not you have control of that viral load that you've been carrying around for most of your life. Now, the clinical manifestations of some kind of a reactivated virus in the chronic setting, that can be very nebulous, very general. It's things like fatigue, brain fog, sleep disturbances, unexplained joint and muscle pain, just a general sore throat, headache, fever, GI upset, very nondescript, and sometimes skin rashes. And some of these viruses actually can affect your thyroid function, and some have been implicated in either triggering or perpetuating various forms of autoimmune diseases. And I'm not giving you this list and telling you that you have to have all of these symptoms in order for someone to say, hey, you have an active chronic virus. You can have any mix to any degree. So you might have more brain fog and fatigue. Someone else might have a chronic virus and it's more joint pain and skin rashes, right? So some people, again, with an active Epstein-Barr could have severe fatigue. Others might have mild fatigue. Some might affect their thyroid, and other people have the same virus, but it doesn't affect their thyroid at all. I also want you to consider that when someone has an acute initial infection, it's quite clear-cut and obvious, right? Acute mono looks like acute mono, right? It's very easy to recognize. But when someone has a persistent low-grade infection, everything starts to get blurry. The picture gets a little harder to define, or I should say the source gets harder to define and pinpoint, which is why sometimes we test for chronic viruses when someone has ill-defined symptoms and there's no clear-cut diagnosis or no clear-cut problem. In other words, the chronic symptom picture is not quite as clear-cut and well-defined as the acute infection picture. Sometimes the lab tests that we run on a routine basis can give us some very good clues here, right? So let me start by saying this, that the white blood cell portion of the CBC, or the complete blood count, can be quite helpful in guiding our understanding of the immune system, but it's a very simplistic surface level assessment. The immune system's pretty complex, and especially nowadays, there's a lot more detail and complex breakdowns that are available to us. And while there are many different laboratory patterns or different ways that the CBC can show us a white blood cell pattern, let me just share with you some of the most common ways, or perhaps the most common way, that these chronic viruses might show up on your white blood cell count as part of your CBC. But before I do that, let me explain what I mean when I say CBC with differential. That's the test that most doctors are going to order, even when they do basic labs. Like usually it's a CBC with a differential and a metabolic panel. And those are really two very simple tests. They can be quite insightful. It's funny how some doctors think, well, that's a lot of testing. And some patients think, well, my doctor tested everything and all they looked at was a CBC and a metabolic panel. That's really not all that much, especially in complex health problems. So again, as I said before, the CBC means complete blood count. And it includes not just your white blood cells, but it includes all your red blood cell markers that help us to find and define different types of anemias. That's a whole different discussion. We had that back probably in one of the first episodes in this particular series. So your CBC, your complete blood count, has white blood cells, and the white blood cell portion is further broken down in the differential. And that means very simply that the differential is a list of the subtypes of your white blood cells. And in general, these different white blood cells, or different types of white blood cells in the differential, are used to respond to different types of infections. For example, and guys, this is generalities, right? Don't take this to the bank as an absolute. These are generalities. We use them as guides in the clinical thought process and clinical decision making. So if we know that we have an acute bacterial infection, these will typically cause an increase in the neutrophil subtype of white blood cells. So if we see high neutrophils, we start to think this is probably a bacterial problem. On the other hand, acute viral infections tend to increase a different subtype of white blood cells, and these are called lymphocytes. And neutrophils and lymphocytes together make up the vast majority of your white blood cells total, somewhere around, let's say somewhere around 75, 80%, somewhere around there. So we can look at the differential as part of our white blood cell count, as part of our CBC, and we can see clues as to what type of infection we might be dealing with, right? And without getting into the weeds, because we could go many layers deep here, we could go a little bit more broadly. Chronic infections, like I've been talking about, usually show up with two things on this CBC with a differential test. We usually see a low normal or low white blood cell count. That's the total. Plus, with viral infections, chronic viral infections, we'll tend to see an increase in the lymphocyte subtype in the differential, because that's predominantly the cell type that your immune system uses to fight against viruses. Right? And that's a very common lab pattern that tells us that we might be dealing with a chronic virus, but it doesn't tell us which virus it is or if that virus is indeed reactivated. So this particular lab pattern is a red flag. It's a thought provoker. It's a point of concern that should make us ask the question, is there a viral infection, chronic or acute? And is this chronic virus, if it's there, reactivated? And should we do more testing to find out specifically which one it is? Because that could lead into much more management or much more effective management strategies. So let me do a super quick review here. Number one, everybody has a chronic viral load. Everybody does, and we pick them up mostly in childhood and adolescence. Some come on a little bit later in life, but everyone's got a viral load. Most people, however, have competent immune systems, and they keep those viruses in check, where the viruses are quiet and controlled, even though they're there. But under certain conditions, and as we age, we lose a degree of immune competence, we lose control, and the viruses that have been there for years can reactivate, and they can cause problems. And not only can they cause things like fatigue, brain fog, or affect your gut or your thyroid, they can trigger different autoimmunities and generally make everything else you have worse and harder to fix, simply because reactivation drives inflammation. Now, finding these infections starts by looking at your symptom pattern, looking at a common test called the CBC with a differential, and looking for that classic pattern. It's not always there, but it usually is, where we see a low normal or low white blood cell count with an increase in the lymphocyte subtype of the white blood cells specifically. Again, that's the most common and the clearest pattern that we look for. But consider this. There's no rule that says you can only have one infection at a time. And since bacterial infections, like we might see in someone's gut, tend to shift the lymphocytes down and push the neutrophils up, as I mentioned earlier, that's the opposite of what a virus does, right? So a bacteria tends to push up the neutrophils and depress the lymphocytes, but a virus pushes up the lymphocytes and depresses the neutrophils. And I know sometimes it's a little hard just hearing it to kind of picture it in your mind, but think about two different sides of a teeter-totter. Whether you have a virus or a bacteria tends to push one end up or down. What happens if you have both? What happens if you have an active bacteria and an active virus at the same time? So let's say someone has a gut infection. Maybe it's H. pylori, the most common gut infection in the world. But at the same time, they also have a reactivated Epstein-Barr or human herpes virus 6 or cytomegalovirus or any other virus. These have opposite influences on that lymphocyte subtype, which we use to try to identify viruses. And so if you have a bacteria that wants to push that number down and a virus that wants to push that number up, they can average out and it can sit right in the middle and look completely normal. So again, what I shared with you is the very clear-cut, very common way of looking at things, but it's not the only way things can show up, which is why it might be important to work with someone who understands these nuances of the immune system so that they can help you decide if chronic infections are a problem for you and look at your CBC and differential for these classic clues and some of the nuances that might be there. Now, one final thing, we now have multiple research papers that implicate chronic viral infections, especially Epstein-Barr, human herpes virus 6, and cytomegalovirus with long COVID. And this is not a COVID lecture, and I certainly don't think of myself as a COVID or coronavirus expert, but this is what's published in the literature. So statistically speaking, long COVID is more likely to happen in people who have these viruses in their system and have poor control at the time they get infected with coronavirus. And some experts are now saying that coronavirus 2 will become seasonal like the flu. We don't know yet, but some experts are saying it's probably going to happen. And so it's important for us to be able to find those people with these other persistent viruses and help them restore balance, control, and competence to their immune system to do everything we can think of in preventing someone from progressing to long COVID if they do get infected. All right, I'm going to leave it there for today. Just a reminder that you can check out my lab shop, get access to the same testing that I use in my one-on-one coaching. I do one-on-one coaching, so if you feel like you need more specific and personalized help, you can certainly use the link in the description to reach out to me. I'd be happy to chat with you to see if we would be a good fit. And also a reminder that I do have a handful of self-learning, self-guided online courses that you can access on my website. Just look for the tab that says courses, I believe is what it says. All right, guys, we'll be back again with the Inflammation Nation. Thanks for being here.